videotaping. No.
What's up, math scholars? It's Friday, and my class is not that excited we are videoing in here, but it'll be great. However, we'll go as far as we get today on this video, and then I'll make a part 2 of the video for anybody who's going to be absent Monday and needs to watch part 2, because they'll have to take their quiz early. So I am asking you to take your quiz early if you'll be absent on Tuesday. Number 1, what did everybody do first? Add the 25 to both sides is correct. So that'll give us 10x to the 5th equals 2430. Does that look about right?
Yeah.
Okay, what'd you do for your second step?
Divide 10.
Divide by 10. And that gives you 243. And what did you do for your final step? They're trying to think of the mathematical term. 5 math 5. So the 5th root. Take the 5th root on both sides. And I'm glad he reminded us where the button is. So it's 5 math 5. And this is a perfect 5th root, so we kind of lucked out. What did you get? Now, is it plus or minus 3 or just 3? What do you guys think?
Just 3.
Just 3. Very good. Because when you take an odd radical, you only get one answer. Okay? Survived that one okay? Number 2. So that 7 is actually trapped right now, and you have to kind of get it untrapped. Do you know what the first step should be?
4 math 5.
Yep, take the 4th root on both sides, and the calculator, that would be 4 math 5. So we're going to take the 4th root on both sides. Now keep in mind, we're taking the 4th root. That's an even root. So we are going to have to throw that plus or minus out front. What's the 4th root of 625? It's a perfect 4th. 5. Why did the plus? Okay, I heard the question. Why did I put that plus or minus? Anytime you take an even radical, like a square root, 4th root. Oh, okay. What are you asking? I'm gonna talk. Hey, people on the video. She actually had a great question I want you to hear. She said, go back on number 1. Why did we not put the plus or minus there? Well, anytime you take an odd radical, there's only one solution. But anytime you take an even radical, there's 2 solutions. For the most part. Now, if the answer is 0, then there's only one solution. 2 solutions. Mess. Okay. Well, here's where we're at. X plus 7 equals plus or minus 5. We still have one more step. What should we do? Subtract the 7. And then you got to really use your brain. You have to do positive 5 minus 7. That would be negative 2. And you have to do negative 5 minus 7. That's a tricky one. Negative 12. So you have 2 separate and distinct answers. Okay. All right, we're back. Number 3. Explain how you can find 8 to the 2/3 in your head. Now, I know you can just type it in, but we want to talk about how we can utilize radicals. Do you remember where the 2 would go and where the 3 would go? The 2 would head to the right. He's going to become an exponent. The 3 would head to the left. He's going to become the jail guard of the radical. So this would be rewritten as the cube root of 8 squared. And now you can do it in your head. What's a cube root of 8? 2. And then what's 2 squared? 4. Oh no, I thought maybe my new board wouldn't do that. Oh, it's still lined up though. Alrighty, we're on number 4. Anytime you're going to be adding radicals, you really need to make sure you have like terms. Do we have like terms here? Not so much. So let's use some simplifying to maybe get those like terms. We're doing square roots. You want to use your perfect squares to simplify this down. How can 32 simplify down into 2 numbers so that one's a perfect square?
4 and 8.
4 and 8 are a great idea, but 16 and 2 is a better idea? Because 16 is the largest possible. You want the largest possible perfect square you can pull out. Well, I see what you mean. Then we're not going to match this, but we're going to reduce this down as well.
Well, what if you just reduce 4 of those? Therefore,
All right, we're going to show Logan his way will work. Let's do it your way, Logan. So you want 4 and 8? Your way works, and my way would work too. What's the square root of 4? 2, and when that 2 joins that 2, it's a 4. So we've got 4 radical 8 plus 10 radical 8. And now we're happy campers because they're like terms. If you have 4 apples and you get 10 more apples, you have 14 apples. But then we still have to reduce our 8. So let's go ahead and reduce our 8 down to finish it off. 8 is 4 and 2. And what's the square root of 4? 2. And when that 2 joins that 14? 28. So that is the answer. I would have gotten to that same point doing it my way, but hey, I like that way too. That's why I like math. You can take any path you want as long as you get your path ends at the right answer. All right, we're back. Number 5. I kind of want to add, basically get the 49 into one single base 49, but that's going to require me to add the 1/3 and 1/6. So honestly, this is just a lesson on, do you remember how to use common denominators? What's a good common denominator for 3 and 6? 6, good. I think you're learning. So we're going to turn that 1/3 into a 2/6. 2/6, because you multiply 3 by 2 to get 6. You multiply 1 by 2 to get 2.
So it'll be 1/2.
Well, we're getting there. We're getting there. They're jumping to the answer, everybody. All right, so yes, the answer is 1/2 because it's 3/6, and 3/6 is 1/2. Now, I did have Brianna up here say, so do I leave it the 49? I've got news for you.
No.
You can actually simplify this further. If you take the 1 to the right and the 3 or the 2 to the left, it just becomes the square root of 49 to the first power. So what's the square root of 49? 7. So just put 7 and be done with it.
Well, how can you know that?
I actually think the one on the actual quiz itself is a number that's not a perfect square, so I don't think you can go that far on the quiz. Yes, so I just had the question, hello people in the video, if there's a Polaris portion, there's 10 questions on Polaris, and then I think 6 questions on paper pencil.
Did you see them?
No. Alright, number 6, we're going to break down that 4,000 so that one of the numbers is a perfect 4th root. So, what did you go with? Anybody that started this one yet?
Too hard. I forget. 16 and 2.
16 and 250. Yeah, I think that's what I did yesterday. I was working on this one yesterday with someone after school. Are we on number 5? Yeah? Okay. Oh, okay.
Oh,
so
it's
it's
4th roots. I did it as a perfect 3rd.
Oh, it's a perfect 4th. So the 4th root of 16 is 2, because it's 2 times 2 times 2. So that 2 will come out front. Go ahead, if you have not yet, give yourself an empty answer radical that you can start putting things in. Leave a bunch of blank spaces here, because you're going to have X and Y's most likely. So the 16 come out, the 250 I believe stays in, and that's about as far as that 250 can go, because it's not divisible by 81 or 16.
It is divisible by 1.
And 5. So if you're ever unsure if you can go further with something, you can always make a factor tree, which is what I was doing after school with these kids. It was 25 and 10, and then 5 and 5, and 5 and 2, but I couldn't get 4 of the same factor. You have to be able to get 4 of the same factor. So that is about as far as that one can go. All right, let's do our x's. We did that with long division. What's 13 divided by 4? 3 remainder 1. So 3 x's get out, 1 stays in. And then let's do our y's. What's 20 divided by 4? 5 remainder 0. So 5 y's get out, none remain in. That's your answer. It's kind of an obnoxiously large radical, but it's okay. There you go. All right, why don't we do 7 while we're here? While we're talking. All right, I had some people chatting and they're like, I can't quite break that 100 down into a perfect 4th root. Well, let's put the 32 and the 100 all together under the same radical. 32 times 100 is what? 3,200. And then let's see if we can break anything out. First of all, I like to see, is 3,200 a perfect 4th root? Because if so, we just hit the lottery.
No, it's not.
And then that's when you go, drat, I didn't hit the lottery. Good life lesson, you normally don't win the lottery. All right, so how do you guys want to break the 32 down? 16 and 200. So 16 is a perfect 4th root, 200 is not. The 4th root of 16 is 2. But let's see if there's anything else that can come out of that 200. Is there on the perfect 4th list, like 81 or 16? Probably not, and I'm going to do that exploratory factor tree because I just kind of always freak myself out that there could be more to come out. So 200 is 100 times 2, 100 is 10 times 10, 10 is 2 times 5. So do you see 4 of the same factor in the jail? Not so much. We only have 3 2s and we have 2 5s. So 200 is about as far as I can go. So that factor tree is just a way of me exploring if anybody else could possibly come out. All right, hello scholars, we're back. We're on number 8. We're trying to take h of t minus j of t. And I'm sorry, those are typos. All of these should have been h of x, j of x. Okay, sorry if that confused you.
Oh, that's good.
Typo alert. So anyways, we're going to take the function h. Logan, we started. We're taking function h and we're subtracting off function j. And the whole idea here is you are subtracting off a group, and that negative has to distribute into everybody. So we'll have 3x plus 2 minus 4x squared minus 2. And then you can simplify. So the 2's go away. And your final answer is negative 4x squared plus 3x. That's the answer for answer blank A. Now answer blank B, what's the domain? What do you guys think? What could we put in for x? Anything we darn want, because you can square and multiply by any number in the whole world. So negative infinity through infinity. Wait.
Dumb.
We are at number 9 now. They want us to take f of x and add it to g of x. So here's f of x. Here's g of x. Are they like terms? Are they like apples? Yeah. So you can put a 1 there to help you thinking. If you have 5 apples, you add 1 apple. How many apples would you have? 6 apples. So that's the answer to part A for what is f of x plus g of x. And then what's our domain now? What are we allowed to fourth root?
It would be 0 through infinity.
Good. 0 through infinity. Now, Zoe, do you want a bracket or parenthesis on your 0? Good, because we can take the fourth root of a 0. Very good.
0.
0 through infinity. To infinity and beyond.
Your kids like that movie?
I don't know if they've seen it.
There's another one.
Moving on.
It's more so.
Alright, we are on 10. We've got 3x plus 5 for f of x, and g of x is 2x plus 1. They want f of g of x. So we're circling g of x and sticking it right about there. So it's going to be 3 parentheses 2x plus 1 plus 5. So you just got to really be aware, are you going to have to FOIL? Are you going to have to distribute? Because all that stuff can happen maybe on the quiz. So what are we doing here? Any FOILing? Any distributing? What do you think? Distribute the 3. So it'll be 6x plus 3 plus 5. And then the 3 and 5, of course, can add up to 8. That's your answer to part A. And they want the domain again. What numbers can we put in for x? We're just multiplying by 6, so anything we want. At negative infinity to infinity means anything we want, any number in the world.
Wait, that's fine.
That'd be amazing. All right, number 12. We're going to try to power through and finish. I'm not sure if we'll get to 13 or not.
Come on.
Find f of g of 2. So we just learned this yesterday. It's real fresh in your mind. You're going to put that 2 in for g. What is 3 times 2 plus 1? I heard somebody say it. It's 7. So then you have to find f of 7. So you take your 7 to function f. 4 times 7 squared. Remember to square that 7 before you multiply by 4. So that would be 49 times 4. 196. All right, part B. f of negative 1. You have to be real careful on this because you will be squaring a negative. So you're going to start here by putting a negative 1 in function f. What would that solution be? 4. Very good. And then you're going to find f of 4. So f of 4 would be 4 times 4 squared. 16 times 4 is 64. So that's the answer for part B. Part C, find f of g of x. So you're going to circle g of x. Ooh, this will be fun. You gotta stick it right there. Sometimes there's distributing and foiling required. Ooh. What are we gonna have to do on this one?
Nothing, just leave it.
No, not so much. So you're gonna have to write it 3x plus 1 twice. Good. Let's get there. We'll get there. I like to start with these two probably and leave that 4 until last. We'll deal with that 4 later. So here goes my foiling. We'll have 9x squared. We'll have positive 3x. We'll have positive 3x. And we'll have 1. You still have that 4. Don't lose your puppy. You'll have 9x squared plus 6x plus 1, because these will combine. And then you can distribute your 4. So it'll be 36x squared plus 24x plus 4. We are going to try to finish the last one, because I don't want to make a separate video for one single problem, okay? Oh, what's the domain? All reals, of course, because you can put anything in for x.
You move us too fast.
I know, I'm just keep watching the clock. Sorry if I'm going too fast.
But
What is the domain of this function? So what are we allowed to divide by in math class? Any number in the world except 0. So we mainly just want to avoid that denominator being 0. So you can kind of think about it this way. I never, ever, ever want 2x plus 5 to be 0. Did you already figure it out, Logan? Negative 2.5. So I divide by 2, and I figure out that x can be any real number in the world except negative 5 over 2, or if you like decimals, negative 2.5. So here's how I would write that. My domain is negative infinity to infinity, except x can never be negative 2.5. Well, thank you for letting me finish this video in one period. I think it will be more convenient to our viewers this way. Hope you have a happy weekend filled with no homework. Who's excited about that? Ta-ta.
I know.